Okay, students, let's start today's session, which is our second topic, which is address resolution, okay? Which is actually our ARP, address resolution protocol. So this will be a short session, but it will give us some insight into the concept of address resolution and how ARP and network discovery enable communication on a network, okay? ARP for IP version 4 and ND for IP version 6. So we'll look at the concept of both MAC and IP addresses, ARP and ND. We know that we have a MAC address, which is a hardwire address on our network interface card, and it works at layer 1 and layer 2. And we know that we have got an Internet Protocol address, which is a logical address, and it works at layer 3, network layer. Okay? We know this. We start the session with this. Now, let's move on and get some more information. We have got two primary addresses. Layer 2, physical address. Okay, remember layer 2, data link layer. And that physical address is known as your MAC address. It is used for network interface card to network interface card communications on the same Ethernet network. Okay. We also have a network layer, also known as layer 3 logical address, known as the IP address. Okay. It is used for sending packet from source device to the destination device. So layer 2 addresses deliver frames from one NIC to another NIC on the same network. If you are sending your layer 2 address to an outside network, it will only register the gateway's MAC address. Okay. So if you are, for example, over here, if you are sending from one network, okay, question, look at this network, okay. It is one network /24, okay. This is another network /24. Are they on the same network? Yes. If you look at the network address, /24 means network address is 24 bits. That means 8 plus 8 plus 8. So look at this. Are these two the same numbers? Yes, they are the same numbers. That means they are on the same network. The host portion is only different. So they are on the same network. Okay. So when you're sending from destination, okay, so destination has got, sorry, when you're sending from source to destination, you have the destination MAC address and you have got the source MAC address. Similarly, you will have the source IP address and the destination IP address. Okay. Those information will be actually inside the fields of the packets or frames that you're sending. That's what we have been studying both in the lecture and in the lab. Okay. Now, when the destination IP address is on a remote network, then the MAC address, the destination MAC will only be of the gateway, okay, or the first router connection. In this case, for example, is gigabit 00. So we use ARP, also known as Address Resolution Protocol. So what is ARP? ARP is used to associate your logical address with your physical address. Okay? In other words, every device will have a network interface MAC address as well as a logical address. So ARP will tell you this device physical as well as logical address. This device MAC as well as IP address. So, for example, over here, you are sending a information to your destination from a source. Okay, so when you're sending it from this device, okay, it will say, hey, this is my destination MAC, this is my source MAC, this is my source IP version 4, and this is my destination IP version 4. Now, the first thing you have to see over here is look at the source IP version 4. This is a /24 network. Okay, so that means network portion is the first 3 octets, 24 bits. So 192.168.10. Destination is also /24. Look at the destination. Is it the same? Look at the destination network address and the source network address. Is it the same? No, it's not the same. That means you're sending to a different network, correct? The source IP and the destination IP address is not in the same network. They're on 2 separate networks. So as far as our logical address is concerned, we know they are on the same, not on the same network. They're on different network. So your logical address can know what is the source IP version 4 and what is the destination IP version 4. But your MAC address will only know what is the source MAC and what is the gateway MAC. That's it. It won't register the destination's MAC. Okay? Once it goes over here, then the router will have the trouble of finding the destination's MAC and all that. That one we leave to the router and its intelligent routing algorithms. Okay, find the next router, and this router perhaps will have information about this MAC. Just remember, the moment you're accessing the outside network, the destination MAC for an outside network will always be your gateway's MAC. And by gateway, I mean the outgoing connection. Okay. So usually ICMP version 6 is used for IP version 6. ICMP stands for Internet Control Message Protocol. Okay, there's so many protocols that we have to remember. So ICMP version 6 is used for IP version 6 to associate IP version 6 address of a device with the MAC address of the device and IC. Just remember, whenever you are going out of a network, the destination MAC will always be the MAC address of the gateway. Now let's look at ARP. ARP is used by all devices to know what is the MAC address and what is the IP version 4 address. Okay. ARP provides 2 basic functions: resolving IP version 4 addresses to MAC addresses. Okay, and it has to maintain a table known as an ARP table. In the ARP table, you will have a MAC address and the corresponding IP version 4 address. Okay. So for example, a device can say that I need to send information to a computer on the same network, but I only have the IP address. I don't know the MAC address of the device. Okay. So you can send that ping, and then that MAC address can be sent to it. Okay. That MAC address can be sent, and then it updates its ARP table. Now it knows that, hey, this logical address has got this MAC address. Okay. And then it can send its information to that MAC address. Now, let's go through this. To send a frame, a device will search its ARP table for a destination IP version 4 address and find for a corresponding MAC address. If it is on the same network, the device will search the ARP table for the destination IP version 4 address, and it will forward it to that address. If the destination IP version 4 is on a different network, then the device will look for the IP version 4 address of the default gateway. Where will it look? Inside the ARP table. Okay. If there is no ARP table entry, then, like in this situation, if you don't have the MAC address of this computer or device, then you send an ARP request, as we have over here. Once you send the ARP request, this request will be replied, and then you will have the MAC address inside the ARP table. Whatever entries you have in your ARP table, unfortunately, they're not permanent because the network is supposed to be scalable. You can add devices, remove devices, okay? So the ARP cache expires after some time, okay? This ARP cache timer differs depending on the operating system, which operating system you're using. The timer and the time of this ARP is different. Actually, you can manually change the entries of your ARP by an administrator, okay, a network administrator. For example, this device or this computer will remove its ARP entry if it doesn't use it for 2 minutes. Okay. And then it can also, update. And if this entry is removed, what about the other devices? How will they find it? Very simple. They will send the ARP request and then update the ARP table. Okay. So they keep pinging each other to update their ARP table entry. In order to find out what is the information you have in your ARP table, then you give the command show IP ARP. Okay. On your Windows system, you can type ARP/A to get information about. This is a pretty powerful command. Okay, like in your router, it will tell you that, hey, this is my internet outgoing address. This is my IP address for my if you remember, gigabit Ethernet 000, and its relevant MAC address. Okay, you have to be very careful with these information in your network, my dear students. Remember, MAC addresses can be spoofed. Okay, you have to protect your network always. For those of you who are studying cybersecurity, you will understand this. You will know that this is much, much important because hacking is very much doable using simple tools. Okay? So you have to make sure that this address is well protected. Your MAC address should not be advertised. Again, for your PC, you see, it tells me that this is my connection to my router, and this is perhaps the MAC. These are the internet addresses that I have on my PC. Perhaps this is a connection to one device. This is one of the connection to another device, and these are the MAC addresses, and they are all using perhaps OSPF, dynamic routing. Okay, you can try this on your home computer as well. It will show the IP address of your router, outgoing router. Okay, And the outgoing router address of everybody in the network is the same, unless they change it. And if you access the Wi-Fi, if you just go and access the Wi-Fi of any other person in your area, you know that what is their internet IP address most probably is 192.168.1.1. And usually people don't have the intelligence or the smartness to change it, or the know-how to change it. Now just imagine if you can access that, change the password. Usually people, if they don't give a password, you can actually take control of it. So hacking is actually a very easy thing to do. It's not something that you can do only after going through a certain course or certain uh, period of training. You can start hacking by just going to one website and reading one paragraph. That's it. So what I'm trying to tell you, network engineers, these commands are not, they're not just another command. You can get a lot of information from these commands. Yeah, this is what I was talking about. For example, ARP requests are received and processed by every device on the local network, because every device has got an IP address and has got a MAC address. So there should be an ARP table in every device, correct? The problem is if you keep on sending ARP broadcasts, it will slow down the network, okay? And there's another issue. ARP replies can be spoofed. For example, this device is trying to find out what is its gateway. Okay, I want to know my gateway address. Now, you can actually, what you can do, you can change through smart programs, third-party software tools. You can change and send, because you get the ARP request. The moment your program detects an ARP request, you can say, hey, I am your exit default gateway. Talk to me. So then this will be, so what you're doing is you're spoofing your router's gateway. So whatever information that you want will go through this now. Okay? And once this has got access to your device, and it can get a lot more information. So you can do this, okay? But usually, what we do, our Cisco switches, they have got security in them that they make sure that they can check which is a valid. That's why most of the devices that come out after lots of research and after lots of experiments, they are much more secure than the previous devices. So enterprise level switches include mitigation techniques to make sure that this does not happen. This kind of ARP attacks do not happen. But then as network engineers, you should always be one step ahead, okay? So one thing that network engineers do, you may not know, is try to find ways and means of attacking their own network, okay? Or what people usually do, they pay money to a third-party company who specializes in this thing, especially banks and other sensitive organizations. They pay certain companies to find loopholes in their network. And then these people go and say, see, I managed to get into your network through this and this port, or this and this door. So you have a loophole. And then they fix it so that if there is no major damage, if a real hacker does that, to bring down a company, you should remember that information is very sensitive. Think about big, big companies and enterprises that are doing business. For example, Amazon would like to know how Netflix brainstorms and gets ideas. Amazon, for example, loves to know all the secrets that SpaceX has for getting us to Mars. Okay, again, SpaceX would like to know what information Amazon is, how they do their business in Amazon, and they get trillions of dollars. So the same information war is going on between these major companies, and security is actually a very important issue. Everybody wants to know the trade secret of other companies, and then you have to be very careful if you're a network administrator. You have to be very, very careful, because accessing data from a network is actually not difficult, my dear students. Like I told you, just read one paragraph. Go to the internet. If I give you a certain website, you can just go one paragraph. That's it. You can bring down an enterprise network down with just that one paragraph. No, sorry. I don't know. I'm just giving you an example. Look at this guy. And the reason you have to know these things is so that you are one step ahead. And all this information that you have is translated into dollars, into money, because people want your know-how. People want to know how you're going to protect the network. So if you know something that somebody else doesn't know, that means you deserve to get paid better, right? Okay, so think about it in that terms. So spoofing is a real threat. Despite the devices, the latest devices that are out there, which try to decrease spoofing, even certain apps like WhatsApp, previously spoofing was easy, but now it's not. Still, there are ways and means, that, hackers will try and find out something that perhaps you didn't think about before, okay? That said, even the switches and the routers that we use, security-wise, you have to be very careful. If you watch this documentary about Edward Snowden, Citizen 4, where he says something very scary. He says that the Cisco routers and Cisco switches have got a backdoor entry that only the Cisco engineers can come through. It has got a backdoor entry. That means there is ways that people can still, hack your network. So actually, I'm not so sure how much of that is true, or he's just saying something. But maybe we have to do research to find that out. And perhaps that's one of the reasons that the U.S. Is having issues. Many of the Western governments have issues with Huawei and its switches and its network equipment and its routers. It's because of perhaps this. Okay, so okay. Curtin was sponsored by Cisco. No, Cisco is a networking company, and it has got all these networking devices, and it is the networking standard of the world. And in order to learn networking, we have to go through its academy, and that academy is Cisco Certified Network Associate, which you are doing now. You're doing CCNA-1. Okay. Hamza, what did you share? Yeah, perhaps, perhaps, spoofing information we shouldn't share here. Perhaps we can learn these things so that we can defend ourselves from external threats, okay, which we call threat actors. There's so many threat actors out there who actually would like to attack, not because of financial gain. They just want to do it to, feel superior or feel good about themselves, that, hey, I can do this to you. I can bring your network down. So we all have to be a step ahead, especially if you want to be network engineers. It's not easy being a network engineer, my dear students. Remember that. You need a lot of aptitude and a lot of sleepless nights. Okay. Just a few weeks ago, if you noticed, our Curtin network was down. We couldn't access Moodle. Just a few weeks ago, we couldn't access Moodle. And the whole issue was one of the switches stopped working. And they had to replace that switch. Now, replacing a switch is not so easy. Just remember, the switch has got so many commands, so many configurations, running configuration. And if you don't have a backup of that running configuration, okay, if you don't have a backup of that running configuration in another replacement switch, how you want to replace it? Again, you have to sit down and type all those iOS commands. Okay. Now just imagine you are the network administrator and this happens. You will have telephone calls from the PVC. You will have from the CEO, from the students, everywhere. While you're trying to solve that, sitting in front of your iOS commands console and typing and trying to solve it, you will have calls. When will it be solved? What will happen? How? When? Just imagine you're the network administrator. It's not an easy job. It's a nightmare job. Okay. And if you don't deliver, you're out, you're fired, or you're on your way to be fired. But if you deliver, you will gain a reputation and you can actually get a good salary out of it. Now, our IP version 6 follows something called ND. ND is what IP version 6 actually works with. It's known as Neighbor Discovery Protocol. It has address resolution, router discovery, redirection services. Okay. So how does it work? It uses ICMP version 6 to do a NS, neighbor solicitation, and also neighbor advertisement. In that way, it can get the information about all the devices in the network. The ICMTP version 6 router solicitation, RS, and router advertisement messages are used for messaging between devices and routers. That is if they're using IP version 6 address. Okay. So something like this, if you are using IP version 6 address, for example, this one can say that whoever has got .11, send me your MAC address. And then say, hey, I am .11, hey, you are .10, and I am .11, and my MAC address is this. So it will update its ARP table. Okay. So that's how it works. So that brings us to the end of our chapter 9. Okay. Address resolution, which we can do for both IP version 4 and IP version 6.